Why are we so interested in factoring polynomials anyway? Well, the answer to that is factoring polynomials is going to help us to solve polynomial equations. What's a polynomial equation? It's an equation with polynomials in it. So technically, a single number or a linear expression is a polynomial. We're only going to consider it a polynomial equation if at least one side of the equation is a polynomial with degree of 2 or higher. Right? If everything's linear, then it's a linear equation. So we're going to be concerned with solving polynomial equations. So we want to take a second and think, what does it mean to solve a polynomial equation? Well, it means the same thing as it means to solve any other kind of equation. It means to find all of the solutions. What does it mean to be a solution to a polynomial equation? It means when we plug it in, the equation is true. So here's a polynomial equation. X squared minus 5x minus 14 equals 0. That's true if we plug in some value of x and work out the arithmetic and we get 0. It's false if we work out the arithmetic and we get something other than 0. So x equals 7. Our equation says 7 squared minus 5 times 7 minus 14. If you like, you can throw that whole thing into your calculator. Just for the sake of the notes, I'm going to write a little bit more of the arithmetic out. 49 is 7 squared. 5 times 7 is 35. And then I've got 14. 49 minus 35 is 14. Minus 14 is 0. So yes, x equals 7 is a solution to this equation. What about x equals 2? So if x equals 2, the equation says 2 squared minus 5 times 2 minus 14. That'll be 4 minus 10 minus 14 is, I think that's going to be, what, negative 20, which is not 0. So no, x equals positive 2 is not a solution to this equation. But x equals negative 2, I'll have negative 2 squared minus 5 times negative 2 minus 14. Negative 2 squared is positive 4. Minus 5 times negative 2 is plus 10 minus 14. So 4 and 10 is 14. Minus 14 is 0. So x equals negative 2 is a solution. So that polynomial equation had 2 solutions, at least. We don't know at this point. There might be more. Here's another polynomial equation. It's given with one side in a factored form, but we know if we multiplied that out, it would be degree 2. We have x minus 5 times x plus 3 equals 9. We don't have to multiply that out to check whether or not we have a solution, right? When x is 6, this equation says 6 minus 5 times 6 plus 3. Right? 6 minus 5 is 1. 6 plus 3 is 9. That equals 9, which is the other side of the equation. So x equals 6 is a solution to that equation. What about when x equals 3? We'll have 3 minus 5 times 3 plus 3. 3 minus 5 is negative 2. 3 plus 3 is 6. So negative 2 times 6 is negative 12, which doesn't equal 9. So x equals 3 is not a solution to the equation. What about x equals negative 4? Well, we'll have negative 4 minus 5 times negative 4 plus 3. That'll be -9 times -1. Oh, that's also 9. So x equals -4 is a solution. And we notice that polynomial equations typically have more than one solution. The big question, though, is how can we find the solutions to a polynomial equation? Our usual move of isolating the variable on one side isn't going to work for us. Why not? Well, because we have more than one variable term, and they can't be combined because they're not like terms. So isolating the variable won't work for us in a polynomial equation. We need a whole new tactic.